Hello, and welcome to the Expert Workshop, Digital Twin for Energy Automation. There's an ecosystem that starts from power system planning, going through the IAD engineering, and ending at the protection testing by Siemens and Megger. My name is Luis Francisco, and I'm a Senior Sales and Business Development Manager at Siemens. And today, I'll be moderating and driving you through this virtual event. On the upper right corner, you see that there's a poll. Please tell us if you see us and hear us clearly. We recommend you to use Chrome, but if you have any issue, please refresh your browser, check your internet connectivity. A LAN connection will be better. And if you have a VPN, notice that sometimes you get latency because of that connection. And if there are any issue persistent, you can go out of the platform and then log in once again. For questions, as you cannot ask them directly to the presenters as they speak, there's a question box that you can type in your questions. Lo mismo aplica para aquellos que hablan español. Siéntase libre en hacer sus preguntas en su idioma nativo. At the same time, our expert will be then willing and glad to answer to your questions. Every time that we have at the end of the presentations, you will see some polls popping up. Give us your feedback, that we appreciate that. So now, let's get started with the workshop. And I would like to start this session asking a question. What are the biggest challenges of our times? You can Google it right now, and you will see that climate change, environmental disasters, or biodiversity loss are among all the hits at the beginning, which means that we are living in a very particular time in our history, and we have a responsibility to do something to mitigate, to tackle, and to reduce the impact of climate change. Now, how to translate that into the energy landscape? What is happening in the energy industry is huge. The ongoing energy transition is posing tremendous changes in the power system as we know it. Those changes are now being clustered in what is called the 3D for decarbonization, decentralization, and digitalization. So why is a huge change? Well, the old legacy or traditional, let's put it this way, power generation technologies are being phasing out and substituted with renewable sources. Also, it is necessary to work on efficiency of the system because, again, our nature requires that kick from our side. The same is happening with the decentralization. When we look at the traditional way on how the system works, we had generation, transmission, distribution, and consumption. Now, that supply chain of the energy system has changed. We see that there's more and more distributed energy, power generators closer to the distributions. We see also battery storage system being plugged into the distribution landscape. Again, there's also non-rotary power generations being plugged into the distribution, and also us, as consumers, we have either solar panels on our houses. You see buildings with a lot of solar panels. So we're not only consumers, we're also producing energy, and we are now prosumers. And all that is unfolding, just in front of us at a rapid pace. We all listen about EV cars and all that. That is a huge change. Then we have digitalization. That is like a frame to all this. With the digital technologies and everything that is in there, we can for sure tackle many of those challenges that we see in the market. Now, when we talk about the ecosystem around energy automation, we start with the power system planning. There, the target is to get a replica of the real physical energy power system. And with that, we simulate the settings that at the end of the day are included in the energy automation and protection systems in all those power systems worldwide. And of course, we have the test equipments because we need to test and test and test again all the scenarios and cases that will ensure at the end that those systems are reacting to the issues the way that we want them to do. Now, after these sessions, you need to be able to answer questions like, how can I more efficiently validate my protection settings? What about how I can manage those longer delivery times due to the logistics and the disruption that is happening in the supply chain? How can I ensure that I can do faster and reduce the time for factory acceptance tests, site acceptance tests when they're on site? And also to train more efficiently market professionals or the people who have interest in the technology. The same, how can I interact better with our experts? It doesn't matter where they are and when. A hint to those questions could be having virtual copies of the products and system, whether they are individually or interfaced as an ecosystem. Now, here I want to leave you with this statement from Aristotle. So the whole is more than the sum of its parts, and definitely this is something that also applies to the digital twins. You see that digital twin can be leveraged across the complete life cycle of projects, products, and also during the operation. And now I have the pleasure to introduce you to our speakers today. In the planning phase, we have Dr. Christian Romeis. Christian is a power system consultant at Siemens with expertise that covers from protection relay and control system and wide area monitoring. We have also Cedric Hairispur. Cedric, who is responsible for the SIPROTEC digital twin, SIPROTEC tools, and also IEC 61850 engineering at Siemens. Also Andrea Bonetti, who is consultant in power system protection and IEC 61850 applications at Megger. He is member of the IEC's standardization committees on protection functions and IEC 61850 and guest lecturer at the Royal Institute of Technology in Stockholm. And that said, I'm going to start handing over here to Christian so he can start working on the digital twin for the planning. Christian, the stage is yours.
Hi all together, also warm welcome from my side. Thank you, Luis, for this introduction of all the speakers. And yes, I'm also here, I'm here from the Power System Consulting, and Luis also mentioned these 3Ds, these challenges which are coming up. These also affect the work of all the protection engineers. And all the protection engineers maybe have to answer new questions here. They ask themselves, okay, how does it affect my system? Is it still reliable, secure, and also dependable? How do power electronics affect my relays or all these different new infeeds which are coming in, volatile power flows between all these different infeeds and prosumers and so on? And maybe you have to answer new questions here. And one idea can be, you can use a digital twin. So how about using digital twins also in design planning of a protection system and later on in all the testings and in all the equipment stuff? And first of all, from our perspective, also from the consulting perspective, we want to give here a definition because you have to know what are you talking about. So our definitions, just here from our perspective, we define the digital twin. So the digital twin is something of what? For a special purpose. So you can have a digital twin from an IED just to assess the relay behavior, or also let them communicate with other hardware devices. And on the other side, you have maybe the twin or a replica, as Luis mentioned, from your power system with all your equipment inside. You have the lines, transformers, and so on. And if you have defined this, so you have a digital twin of what for a special purpose, then you can say, okay, can combine some digital twins, maybe a digital twin of the power system with the digital twin of an IED. So maybe if you want, you can give us a hint here in our short poll if you already thought about using digital twins in this planning or design process or assessment process of your protection system. So on this slide, you see now, I defined or give you some hints what you have to think about if you want to design and plan your power system. We have 3 topics here. First of all, you can think about what are the aspects I want to investigate. So for example, selectivity, sensitivity of my power system with more than 100 relays inside, checking all the gradings, if they are okay. Is the operating time okay? Then I also can check, okay, how is the performance, maybe for one special algorithm or relay. So I want maybe to investigate the inrush detection if it works. I also want to check maybe the communication. So are the goose messages okay? Is the protection interface correctly configured? And if I have the answers on these aspects, what I want to check, then I have to answer the question, the accuracy level. So what do I need? What physical phenomena I want to check? For inrush detection, I need a transformer, a right physical representation in the power system twin, and maybe also I need a relay model, or I need the original relay algorithm, so because I want to test a specific function. And then I have to define the effort. So what effort I have to here to answer my question. So on the one side, it could be, okay, simulation and models is okay. It works for me. I can do the grading diagrams and so on. And on the other hand, maybe to check the performance or also operating times, the speed of the relay, then I maybe have to invest here in hardware laboratory and also testing equipment like for Megger, or I also need an expert who just controls the simulator and so on. And if you have the answers on all these questions, this brings us to this tangent triangle. You have to define your aspects, the accuracy level, and effort. And then you find a spot here in this tangent triangle where you have to fill in how to solve this problem, how to answer the question. And on the first tool or option is using the simulation software. You have relay models inside. You can check all the settings. You can implement the settings. You can check the diagrams. You can do also maybe a compliance testing and get a report of the selectivity and sensitivity. And if you want to check the performance, you typically go to a hardware test. So then you have a hardware in the loop test. And this is here on the low part of this tangent triangle. You need a lot of effort. Maybe you want to check a specific algorithm or function. And you need a very high accurate, let's say, replica or the hardware device, what you want to check. And at the end, we have here this white spot or this gap here. And from our opinion or our perspective, we see the digital twin can fill this gap here. So you have the virtual device with the algorithm and original firmware inside, so you can increase, maybe in comparison to a relay model and a software tool, you can increase the accuracy because you can choose a specific firmware. And you can reduce the effort here because you can do it right maybe on your desk. You have the digital twin, you can combine it then with your software tool, maybe with the fault simulations and so on. So, and this is what the next step. So you have a digital twin, you have your software tools, and then you can combine these. So this is here just to give you an idea about the approach, how you can utilize a digital twin in planning and design, or also assessment of your protection system. Everything starts with your simulation software. You do some calculations, power flow, short circuit, and so on. Then you define some settings. You get these grading diagrams, or also for the distance, the zone diagrams. And you can verify this also with a protection security assessment. You check the selectivity and so on. Then you can optimize this in the tool, and at the end you have a design for your protection system. You have all the functions, you have all the settings, and with the outcome of this simulation and calculations, you have a relay setting study. With this, you're going into your engineering tool. Here you implement all the settings, and normally you can go to the field and implement this in the settings and your testing. And maybe you have another question. So what is the performance? What is the timing? Is the algorithm correct working? So is maybe the threshold for an inrush detection okay in my case or not? And then you typically have to go maybe to a hardware laboratory, and you use a simulator, and you need the hardware device, and you need all the effort around this. And with the SIPROTEC digital twin, or let's say a digital twin of an IED, you can utilize here your software you already have, and combine it with this digital twin with fault simulations we're doing and can do in your simulation tool. And you can combine it here with the configuration and firmware version, and also communications, goose messages, and all the protection interface for differential protection. And you can implement this here, or bring it to the SIPROTEC digital twin. And at the end, you get the relay, or the relay behavior, and also can compare firmware versions. At the end, you have an assessment of the performance. You can also do approvals of the different firmware versions, and you can reduce the effort. And if you're happy with the results, you can also check the results like in a hardware device, all the comp traits and all the fault logs and annotations. And if you're not happy at the end, the performance is not okay, then you can start an optimizing cycle here with interlockings and also auto-reclosing cycles, maybe changing the transfer blocking times and so on. And at the end, you can optimize this here with the engineering tool. And if you're happy at the end with also the performance, then you can go back maybe to your power system or your relay database. In our case, PS Escape can also exchange your information between the engineering tooling Dixie 5. So this could be an approach here, how to utilize in planning and design stage, and also in approval of the relay behavior. So just to give an example here, short example, where we all utilize this. The example is, how does the CT location influences the fault locator results? So we have here a transmission line, we have here a shunt reactor. You have two options to place the current transformer on the left side, on the right side to the shunt reactor. And we ask this question. So the protection engineer thought, okay, I need the vendor algorithm because they are different between all these vendors. You have to check the right firmware version. And I need an accurate power system representation. So transmission line with all the conductors and reactors and so on. And I have to place the CTs here and produce some outputs of the simulation. And I want to avoid the effort in hardware and laboratory. So the answer is, let us combine here the digital twin of the relays and also the simulation tool in the software. So the outcome is, you can simulate 100 fault locations or more than whatever you want in your simulation tool, and you can implement an automated process here, and then you can compare these different CT locations so that you can give a confident answer what happens in the field. So what happens if we place the current transformer here or place it here? So and then you can say, okay, for us, it's better to use it here, and we know what happens if there's a problem, or we can really can have a good feeling of the results of the fault locator. So at the end of my presentation, if you want to start your journey here with the simulation software and planning and design, you can check out these trial licenses. And also, if you're interested in our consulting work, you can check the link for our PTI page. And if you want to leave us here a hint, please use the poll here. And I want to thank you for your attention. I'm happy to have some questions and to give some answers at the end of the session. And now I think I give back to Luis.
Thank you, Christian, for the great presentation. And I mean, I'm sticking there with the tension triangle, the aspects, effort, and accuracy level. and how to leverage on digital twin to help you simulate, verify, and also, having those settings as the outcome of the power system planning. Now, when I have the settings, what can I do with that? I mean, I'm interested to listen the next phase. Cedric, can you tell us something about it?
It's a pleasure. So welcome everybody, and let's see how the journey with the digital twin is going further with the settings, the engineering, and the virtual commissioning. So digital twins can be used for virtual commissioning with the main target of saving your time and your cost. And here we will highlight the scenario of the factor acceptance test during my presentation. So once you get the settings from the planning tool, you need to combine them into the engineering data of your protection system, and then validate that engineering during the factor acceptance test, typically investing time in the test setup, in performing the test, and if required, also travel to the factory where the tests have to be performed. With a digital twin, you can significantly reduce those times and efforts, especially in the area of the test setup and of the travel activities. So let's see how to achieve that. Let us remember maybe the last time you attended a factor acceptance test. Might be familiar with all the associated logistics of sending the equipment to another test lab, and waiting for the device production, for the panel production, the wirings, the temporary setup required for the FAT, and the additional equipment required. So all those steps are just part of the past. This is a major disruption with digital twins that you can skip FAT test setup by using virtual devices and virtual wirings between those virtual devices. So how does it work? You just get a test system, a virtual one, within minutes. For that, just using the same data that you have engineered before with the protection settings and all the functionalities, you export that configuration from your engineering software, in our case the Dixie5, and you connect to the SIPROTEC digital twin, upload your configuration, and you can simulate one or multiple devices at the times with virtual wirings between them to simulate interconnections between the devices. And this can be used then to perform the functional test scope, which is the core of a factor acceptance test. So typically, what are you doing during a factor acceptance test? And here on purpose, I'm not mentioning the wiring test that we will highlight later, but more the functional test. How to validate the front display configuration that is critical for the operation of the device locally later. How to validate the programmable logic with all the interlocking equations or special applications that have been manually configured. To validate the communication between virtual devices using the i650 Goose protocol or using the protection interface for differential protection. And also the possibility to test any protection function, no matter if it's an overcurrent protection, a distance protection, or even a busbar protection device. All those functions can be tested individually, virtually, with static inputs simulating currents, voltages, binary inputs in just a few clicks, or using transient input files that can be generated by test equipment from the power system planning phase or from the test equipment. And the additional benefits, so it's not only about providing the same functional test scope than before, but also increasing it by enabling the parallel work of several persons on the same device or in different devices without any interferences between them, without the need to travel with multiple people to the factory or to the site, just having people working safely from home, from the office, the whole time of the test, or just as a support feature. And here, the example that you see is extracted from LinkedIn from one of my colleagues from Siemens US that has performed just 2 weeks ago a big factory acceptance test on another continent with the end customers 7 hours of time difference. By performing the functions, answering all the questions, and showcasing live what customer wanted to see, just virtually sharing his screen. And the virtual factory acceptance test doesn't end with simulating one or multiple protection devices, but it's also including the possibility to test the protection equipment inside the substation environment with an interface to real hardwares like a real RTU sending the information then to a SCADA system, or the information to a local HMI, or even the interaction with real protection devices that may not have a digital twin yet. On the left side, you see a visual representation of a digital twin of a SIPROTEC device on the notebook, and on the bigger screen, a local HMI. So all those interfaces are based on Ethernet IP protocols. So no matter if you're using the well-adopted IC350 protocol or Modbus TCP or DNP 3/IP or Ethernet protocol supported by a SIPROTEC 5 device can be used to interface with the substation environment. And additionally, a big benefit is also the possibility to provide temporary access to that virtual environment, so that in projects where the protection engineer and the RTU engineer are located at 2 different sites, maybe even 2 different companies, can do the work remotely, not waiting for the real devices to be produced, arranging a meeting, but performing things virtually efficiently. And when that preparation is done, all the virtual tests have been performed. The closed loop interaction between the system integrator and the end customer to add, if needed, additional tests virtually, answering all open questions. Then you can turn to site and prepare for the site acceptance test, where the scope of test will just be a subset of the test, fully prepared virtually, with no functional issue expected, therefore less pressure on site, and no risk of delay for the initialization. Some tests will for sure remain at site, especially the physical test, validating the final wirings at site. If you compare the content that is done typically today at site, you can see that with the best preparation virtually, you can reduce it significantly and then reduce also your time on site and saving then further time and cost. Thank you for your attention, and back to you, Luis.
Cedric, and I keep that last thing that you mentioned about saving costs and timing. I mean, I really see that the benefits of having a virtual setup and reducing the time up to 20% and costs up to 30%. I mean, everybody know that there's a huge impact in whatever is a project that we're running. The second one that I like is the sample of the FIT remotely. So I can imagine myself running some tests already from the Dominican Republic in the Caribbean, which is my home country, and I really like the idea. However, I know that not everything is done virtually. I mean, there's a phase where you have to go on site and you have to do certain things. And here I would like to invite Andrea Bonetti from Megger to tell us something about it. I mean, how to leverage a digital twin on site.
Oh, thank you. Just let me switch my screen. And I think I'm unmuted. Can I just have a feedback that it's working? You see my screen? Can you hear me? Okay, thank you. Yes, Luis. In fact, we can use this technology also for what we can call remote support, efficient remote support. I want to start the presentation. By the way, thank you for all of you for being here, and thank you guys from Siemens for having invited us in this webinar. I would like to start this presentation with a post on LinkedIn from a very high specialist in high voltage relay protection, Mr. Jan Sakonisek, that got interested about this technology and wrote spontaneously probably a post where he wrote that the digital twin technology allows high-level specialists to be present on test activities that are in fact too demanding for the average technicians. And also he wrote, in this way the specialists can contribute to decrease mistakes. So we are not only talking about reducing money, saving time, but we are also talking about increasing the quality of the system product that system integrator will deliver, which is very important. Why commissioning tests are important? Because the commissioning activities has a strong responsibility. The commissioning tests are done to make sure that the system works. Then you take a subset of these tests and you do the maintenance test to make sure that the system is still working or still in this state that we left when we did the commissioning. So the commissioning tests, the commissioning activities, the commissioning engineer have a strong responsibility, and especially the engineer feels this responsibility and definitely doesn't want to have too many doubts. And if you are some commissioning engineers here, you know that you end up in this question, am I seeing something correct? Is it really performing well? And you dig a little bit more and you think, oh my goodness, maybe I'm not using the correct test method, which is possible, that the wrong test method is used to verify something. And then you say, oh, maybe the settings are wrong and this is starting to be problematic. And then you also would like to say, okay, what happened? Should I escalate this issue, which makes a delay in whole the project and everything? Or I pretend I'm not seeing it. Maybe I just thinking wrong, and I suppose I do nothing on that. And then you get the doubt. Oh my goodness! Then I don't want to go on the newspapers. So you go back and you think, what can I do here? And the best you could do is to have a second opinion. The expert or some colleague that you trust that tells you, listen, yeah, you're doing right. There is a problem. No, you're doing wrong, and tell you why you're doing wrong. And that's what we want. Second opinion, with the help of a specialist. The specialist has to help, so the specialist has to investigate and make sure that the problem that the technician is flagging for is really existing. So how you can make sure, and if it is existing, you have to find a solution for that. So one possibility is that a specialist today has to travel to site, which is expensive, and also maybe we don't have the time for that because the specialists are very busy, so it has not been booked in advance. Alternative, which is something we do every day, if you are working with technical support, we do exchange information by mails, or now we can, thanks to God, using video calls, which means many mails back and forth with many misunderstandings. And also during the video call, you have to make sure that you are there at the same time, which means maybe you are not in the same time zone, and it's not really comfortable situation. And the most efficient way to help one person is to have the possibility to have the hardware clones of the relay that he is using, and also hardware clones or the same test set that he's using. So there is no misunderstanding. My test set, this test set, and this relay has this set, except the clones. This is a very good way to help somebody, but the efforts are very heavy, and usually possibility to do hardware clones are typical only from the relay manufacturers. So in Megger and Siemens, we have developed digital twins. A digital twin is a copy of a physical device, and also there is something important, that they can share the same data, and they share the same data through the software tools that drive them. So what happens for the engineer that is in the substation and needs help, he takes a software tool for the relay test set, it takes the test set and reads all the test plans that he's using, and also reads all the configuration and settings from the relay, from the Dixie tool. Then takes the files and sends the files to the specialist. The specialist has the copy of the test set, virtual copy of the test set, and the virtual copy of the relay. And with the same software, he will load the files, test files, into the digital twin test set, and they will load the configuration to the digital twin relay. I will start to investigate, find the problem. Maybe it's a setting problem, maybe it's a test method problem. So we'll propose a solution which has two files, the test plan and also the relay settings. Send the files with the solutions to the engineer that will reuse the tools to load and perform the same test proposed by the specialist after eventually having loaded the new settings and configuration to the relay. That is how it works. And if you look at my slide that I did before, and now we don't do this anymore, we try to do the specialist with the digital twin technology. And you can see that the specialist now can work from home or from his office. There's no travel cost, and its time is used more efficiently. Only very few important mail messages are exchanged with some files that there is a minimum possibility to have misunderstandings, and everybody can work in his time zone. And the use of the hardware relay clones, yeah, we are doing that because we're using software clones that are called actually the digital twins. So fast support, and this technology is now accessible to any relay specialist and not only to relay manufacturers. And now we have managed to have successful help. If I can go a little bit more in details, at the substation site, the engineer will load the special file, read all the settings, and create a special SIM file from Dixie, which will be sent to the site, to the support site, and the support site can create an exact virtual replica of the relay. Same for the test set. We'll read all the test files from the test set, save the test files, send it to the engineer that will run the tests against the virtual test set. Now, he has to connect the virtual test set to the virtual relay, and this connection is done through an exchange of some files that are COM-trade, and he can run the test, read the setting, read the results. So read the test results, investigate, analyze, read from the HMI, read from the COM-trade file generating the relay, read from the event recorder, find at the end a solution. Solution can be different test plans or in different relay protection settings. As I said, take these files, since we can share the same data, which is very important for digital twin definition, and send them to the substation where the engineer will load the files proposed, the test files proposed by the specialist to the test set, and we'll also load the setting configuration to the relay. Then we'll physically connect them, and we'll manage to see that things have been solved. Is it working well? I was happy enough to manage to try this technology just a few months ago. And the answer was from the site, which was several hours away from me, is amazing, and thank you very much. Because, yeah, it's surprisingly, you send some files to this person that doesn't know how, and it magically it works. But I knew that because I had tested all of that before. So out of 10 set files, I sent maybe on 2, the good ones that I wanted to send. And I had to explain lately that I was using the digital twin technology to make sure that things were working. And then he got, I think he got interested in this. And some days later, he had another problem. Say, sorry, can I send you the SIM file for the new settings? So I was confident that he was confident, and he was confident that I was confident. I hope you understand what I mean. I tested myself, I tested everything, and I was happy of the result. So that is my presentation. You can also joke a little bit with digital twins. We've done a movie for that. And I say thank you very much. And I'm hopeful to be able to answer to your questions soon. Thank you very much again.
Thank you, Andrea. And actually very descriptive, the way that you show how exactly you can leverage on digital twin on-site and how you can actually use the test equipment. I mean, the Mega RTMS together with the SIPROTEC digital twin in order to receive those supports that are necessary. I mean, if you are watching, you've been on commissioning jobs, and you know that the time is coming to an end, and that there's a lot of pressure because there's a necessity to, energize the line or to put back into service the complete industrial facility. So you know what you're talking about. Okay, now let's say that we started with the planning, then we went to the configuration and the FAT. Now we saw how it is on-site. Now let's say that our system is up and running. What else can be achieved with the digital twin? Cedric, back to you.
Thanks, Luis. Yes, so last part of the webinar is also to show you an additional perspective where digital twins can be very powerful, and this is about trainings. The Chinese proverb is saying, I hear and I forget, I see and I remember, I do and I understand. And then by yourself why training is the key for safe and secure operation. The better you understand what you're doing, the better the result is. This is why training is key, and training applies to many aspects in the power systems. It can be about protection relays and special protection functionalities. It can be about communication protocols or about a full digital substation with IC50. And trainings cover a large audience, from the engineering planning phase to the configuration engineer, the operator, or the maintenance technician. And today those trainings have been commonly performed with real hardware devices and with such a nice box where you can simulate voltages and currents conveniently. But with digital twins, we're going one step further, providing virtual benefits for real, like having a practice setup for each trainee. Remember the trainings, how many times it was maybe a theoretical training with a trainer and the other one just listening or sharing a test device. The more you can practice, the better you can understand and learn. No software installation is required. Everything is available in one click in a browser, including the engineering softwares and analysis tools. And then no risk about safety. No electricity is flowing. Devices are virtual. Nothing can burn. And you're learning not with a standard device from the training room, but exactly with your devices, with your configuration you're familiar with, and you need to be perfectly trained. And you can simulate also any numbers of currents and voltages virtually. No need for a big test setup to learn about transformer protection functionalities or even busbar protection devices. All those connections are virtually done. no limitations. And those trainings, when performed virtually, can be done also remotely without the travel time and cost to go to the training institute, like the Siemens Power Academy, and also the unique opportunity to extend the training outside of the training hours. If in the evening you're having a question how to do something, just grab the tool, no need to wait for the next day to go through training. And those trainings, we collected very nice experiences the past year, providing them virtually over Siemens Power Academy. But not only internal trainings can be provided with a digital twin, also many trainings are taking place internally within the industry sector, inside utilities. And here, I'm glad to share an example of a German transmission system operator, TransnetBW, which is about to introduce a new technology, innovations for the power supply of tomorrow, using a full digital substation with IC50 and top-down engineering. And as you might be aware, when you introduce something new, one of the biggest challenges is to train all the different employees, all the different departments to make the change a success. And when the devices in a laboratory are not so well accessible during the pandemic, then it is extremely convenient to have that virtual access so that changing innovations can be brought to a larger audience. And this was a feedback from the training that it's really great for practical learning about latest tools, products, and technologies in one click, anywhere and anytime. And those trainings can also be done not only in the power industry itself, but also earlier with partnerships with universities. The technologies is something really interesting to attract the next generation of power engineers. We are all working in a niche market where it's difficult to recruit new employees. It's time consuming to get trained to perform the job required the office or on site, and increasing the practical experiences during the studies, reducing then the training on the job in the industry is also a key to have the best trained employees in the near future. And digital twins can provide value there to make lectures, professors closer to real case scenarios, to have PhD students involved in the industry research without constraints of lab investments, and also for all the students to practice really with a protection relay and not just the theory of the protection algorithm. So if you're interested in that area, let us see the collaboration opportunities and innovation that we can manage with you as a university stakeholder. And back to you, Luis.
Thank you, Cedric. And thank you actually for that clarification, what can be done right after. And I think that digital twin, as you mentioned, just mentioned that can be used not only for protection expert, but also universities can leverage on the technology to form the next generation of protection engineers, which is necessary. We all know that there's a gap in terms of knowledge, so these technologies can facilitate definitely to close that gap faster. That said, for all of you, this is the last, I would say, portion of the presentations, and I would like to just summarize, right, in a nutshell, what digital twin for energy automation is. It is an ecosystem, as you just saw, that goes across the complete life cycle, whether it is protection automation, the power system planning, the engineering phase, whether it is the FAT, the SAT, trainings. I mean, you can really leverage on the technology, whatever, in a project and afterwards. And I mean, saying that, or that said, it is a game changer. I mean, it is definitely a game changer in the power industry. And as we said, and at the beginning, it is necessary to have the flexibility and to have tools that allow us to more efficiently. And this is exactly what can be achieved with the technology. So the next step is we ask you to join, the pioneering team that is working on these technologies to help scale it further and to be part of this movement. For that, I mean, you see here there are QR codes for free trials of the PSS SynCal, PS Escape, and also of the SIPROTEC Digital Twin. Hey, it's all yours. Then let's start our Q&A session. And for the Q&A session, I would like also to introduce you to a new expert, which is Nicholas Wetterstrand. Nicholas is a business development director for protection at Megger, and is responsible for the strategic planning at Megger for test equipment, whether it is for protection relays, circuit breaker, instrument transformer, and primary testing. So let's check on the questions. Let me see, because I've seen that there's already a lot of them. And I would like to start with this one from OO. So, do virtual environment for testing digital twin should be developed by IED manufacturers or electrical test equipment manufacturers? Who's taking that?
Yeah. I can come into the game now, since I've been quiet all the time. The answer is easy. The proprietary information inside any asset belongs to the manufacturer. So each manufacturer needs to develop their own digital twin. There's no others that can do that. It's proprietary information. I know that IEC is working on standards, how we can standardize the environment so the digital twins potentially in the future, the long term, can work in a digital environment, so to speak. But that's quite far ahead as I see it right now. Maybe my Siemens colleagues want to comment.
Yeah, good answer, Niklas. Yeah, support is that a product digital twin can only be delivered by the product manufacturer itself. What can be standardized is the interface between those twins, so that the protection digital twin can interface with any power system planning tool or any test equipment tool, and the other way around, that test equipment digital twin that you having, then Niklas can interface today with a Siemens digital twin and tomorrow with another manufacturer.
Right. I mean, there's another question. This one is from CP. Can we combine a real protection with a digital twin one in order to check the interaction and the way it behaves? Yes,
so we can interface virtual devices with real devices. In the slides, there was one example how that connection can be done over a VPN. So interconnections with Ethernet protocols like the Goose protocols can be done and tested in an hybrid format. Real devices sending Goose messages and virtual devices receiving and sending other Goose messages. So hybrid testing is possible for Ethernet communication.
Okay, great to know. Thank you for the answer. Another one is from GPC. So when I make the test by digital twin, is necessary to test again the relay on-site, I mean inside or on-site? That one, who's taking that one?
I can start to answer, and then we fill in again by others. But yeah, naturally, you need to do tests at the site as well, because the hardware connections, physical connection, that's not tested. But it's very likely, if you have done those things right, that it will work, because the functions and everything and setup is already checked. And again, if you are using the Megger test tool in the digital twin environment, you can repeat those or use those test files in the real world tests.
Okay, thank you for that.
And you can also select what tests have to be performed on site. So we mentioned it can be a subset, so it can be the same scope, but interesting is when you reduce it to a minimum, not testing, for example, all the protection characteristics information, but only the interesting operating points that are required at site to validate that the wirings and the function is fine, but not going into the details that are just part of a virtual test or a factory acceptance test.
Yeah, that's great. Another question, I mean, this one is in terms of capacity. How many IEDs, this is from RY, how many IEDs is possible to integrate and test through digital twin?
So very good. Depending on licenses, you can simulate 2, 5, or 20 devices at the same time today, covering most standard applications such as interlockings between devices at the voltage level, or an automated transfer scheme in an industrial environment.
Great. Thank you for the answer. This one from SM. Is this digital twin device act as an interface between relay and the testing device? Anyone understand that one?
Maybe I understand. I saw the question in written words. Well, let's try to see. We have the two digital twins, to make it simple. One is a relay test set, and one is a digital twin for the protection relay. These two have to be connected together. And at the moment, the interface between the test set has been decided, driven by Siemens, that decides that in IC 6150 we're using Comtrade. Everybody's happy with Comtrade. So the test set, my digital twin, runs a test as a normal machine, but the generators are not really there. The generators are in a Comtrade file. And this Comtrade file is passed manually to the environment in Siemens. So at the moment, the interface is done like this. But we are just at the beginning of this interaction. Later on, we hope that we will have an interaction between the two digital twins, that you can work really physically, virtually connect them together and run the test as you are used in the reality. If I understood the question correct, but if not, write it on the chat so we can see if I managed to understand your question. This is how I interpret it.
Okay, thank you, Andrea. There I have, well, there's many questions. I think the time is running, but I think we can take many of them, even if we go off time, based on your interest, I mean, to the attendees. This is LA. The question is IC 6150 edition 2 used as a protocol for the digital twin technology?
So the SIPROTEC relays use digital twins are the replica of the real devices. So which means IC 50 edition 1, edition 2, or even edition 2.1 is supported in the digital twin. And for those of you that are using other Ethernet protocols like DNP, Modbus, TCP, it is also possible, as well as PMU functionalities, for example. So all protocols that are supported by a real device and running over Ethernet are available in the digital twin environment.
Okay, I'm going to read one in Spanish, but I'm going to then translate it. This is from SV. ¿Existen otros digital twins para otras familias de IEDs parte de SIPROTEC 5? So what I would understand for that is, what other digital twins in the protection environment at Siemens those exist? I mean, apart from SIPROTEC 5. Is there any indication on that, Cedric?
No, only SIPROTEC 5 device and SIPROTEC 5 compact devices are providing a full digital twin capabilities that we've shown in that presentation. For the participants that are using our Rural 5 platform, there exists a light digital twin that is limited to the usage of the front display of the device. So not using the full configuration, but there is a slight variant for just the display features. But in the SIPROTEC environment, it's for SIPROTEC 5 and SIPROTEC Compact, and for other manufacturers, we had the question before. It's up to them to provide them in the future.
Okay. Good. I think I'm taking the last question here from SM. So the question is digital twin a replica for the test equipment based on IEC 62150? I think this is from our major colleagues.
Like even here, the question must be interpreted. We do have relay test sets that are able to generate sample values according to the 62150 standard. But at the moment, my digital twin can do that. But at the moment, my digital twin has been instructed that if you want to run against the Siemens relay, your generators don't exist anymore. You have to create your output in a COMTRAIL file. And on the COMTRAIL file, it doesn't matter if it is analog values, physical voltage and current, or sample values. Still is a COMTRAIL file showing the voltage and current. So we are now pioneering this technology. When we have the interface, flexible interface between the digital twins, we have the twins, so we are ready to implement also sample values data stream. But at the moment, I don't see feasible with the concept that has been done so far. I don't know if I am explaining. Cedric, maybe you can comment that.
I would say that today, yes, as you said, the interface is a COMTRAIL format at the time being, which is sufficient for the majority of the test. And looking at the future, there might be other activities. So if you're interested, can just recommend to have a look at the trial versions of the different products to really see what is possible, especially for all of you with advanced questions in that process bus area. Better is to see what is possible today and how good enough is it for your virtual testing, and everything else is just about shaping the future and together.
Okay. Then thank you. I would like to thank you first, all the attendees for the questions, and thank you all experts for being here and to answer to them. Just for you to know, those questions that were not answered, you will receive those answers afterwards. And for those who wants to actually watch it afterwards, I mean, this complete session will be available on demand. So that said, I think that we're going to call it now. This is everything that we have for you today. Thank you for the active participation, and stay safe and healthy. Take care and see you soon. Bye.